Hi, Miss Claywell here. I am out today to see my sister-in-law's PhD thesis defense and celebrate her graduating, so I will miss you guys. Due today, you will be making progress on the multiple choice portion of the benchmark study guide. During class, you guys will do 7.1 notes, which is drawing slope fields and differential equations. And then due Monday, when I see you guys, is the multiple choice portion of the study guide complete. So we're going to jump into 7.1 today. Okay, so a differential equation. And x and y is an equation that involves x and y and the derivative of y, the derivatives of y's. A solution to that is a set of functions that satisfy that differential equation. And there can be like a singular solution or a general solution. So we have a differential equation, we have a solution to the differential equations, and those solutions can be a singular solution or a general solution. So what we see here in the purple are some examples of differential equations. Notice how we have like the original, first derivative, second derivative, so basically y's and its various derivatives. We have f double prime, f prime, f, so we have like the original, first derivative, second derivative. So basically we have an equation that shows the relationship between the function and its derivatives. So we have the words direct variation and inverse variation. Direct variation is when we have a linear relationship or function where it's like k of x, where k is just a constant, but we word that as y very directly as x. Inverse is when we have the constant in the numerator and the variable in the denominator. So we call that an inverse variation. So I want you to take a second, pause. I want you to read example 1 on your own and see if you can guess the relationship that describes it. Okay, so it says velocity is inversely proportional to the square of the distance s. So my output is velocity. It's inversely proportional to the square of s. So that means s is going to be in the denominator, and then I just put a constant in my numerator. As I look at my options, I see that it has the v of, it uses the t. So all of these are inverse variations or inversely proportional, but they don't all have s in the denominator, and our output is not the derivative of v, but just v. Jumping on to 2, it says an IV administers medication into the bloodstream at 3 cubic centimeters per second or per hour. At the same time, the organs remove medication at a rate proportional to the current volume of medication in the bloodstream. Which equation describes this relationship? So it's going to be the volume of the medication with respect to time. I'm inputting a positive 3 is what's going into the blood, but I'm removing proportional to the volume. So that's a V and a K. The only one that matches this is A. So C is also kind of close. And D, but the only one that really has the clear, I'm inputting 3 and I'm removing some amount V, is A. Okay. For example 3, it's asking us to determine whether the function is a solution to the differential equation f double prime of x minus f of x equals 0. So all we do is let's find f double prime and subtract f double prime minus f. Derivative of sine is cosine. Derivative of cosine is negative sine. So if I have f double prime of x minus f of x equals 0, let's see if this is true. Does negative sine of x minus sine of x equal 0? It does not. So therefore f of x is not a solution. So f of x is not a solution to this differential equation. We're going to keep trying that again. Feel free to pause your screen and try these on your own. I'd encourage you to. So I'm finding the first derivative, then the second derivative, and then just plugging in whatever I have those. So for b, this f of x is a solution. I think this one's going to be a solution as well. Okay. Go ahead and finish this, flip to the next page. So as we kind of talked about on the page before, there's this idea of finding solutions to these differential equations. So we'll learn how to solve those analytically or like number-wise. So graphically is also a way to find all the solutions to differential equations. So if we think about, consider the equation f of x or y prime equals f of x and y. For every point x and y in the domain, it contains the slope, because that's what the derivative is, basically showing the slope of the solution. So if you draw a bunch of the little slopes or the little solution, you'll have a general solution, which is what we call a slope field. So a slope field, I'm going to change my color, will show all the shape of all the solutions. So let's look at this one. Our dy over dx is 3 minus y times cosine of x. We want to sketch that below. That would go through the point 0, 1. So here's my point 0, 1. As we can kind of see, it's making like the cosine or sine wave here. So we can kind of see it going up, down, up. We see those vibes. So when we draw a slope field, there's 3 things that we need to keep in mind. Doesn't need to be exact. Let's go through given point. So in our situation, that's 0, 1, and it must be edge to edge. So I'm gonna kind of like, it looks like it goes up and comes back down. If I follow this way, it goes down and then comes back up. I'm not loving the end of that, but it does not need to be exact. So we're just kind of following the general shape of the line, and as long as you go edge to edge and through the point, it's good. So sometimes it gives you the slope field that you need to draw the curve through, and sometimes you need to sketch the slope field. So sketch the slope field to given equations at the indicated points. So I have 12 points I need to find. Let's just start with -1, 0. So when I put in a -1 and a 0, my output is -1 squared times 1, which is -1. So my slope is going to look like this. When I put in a -1, 1, I get a 0. I put in a -1, 2. I get a 1. So I'm just plugging those in. I'll do this next one in case we're needing to see that. -1 times 3. I'm going to get a 1 times a 2, which equals 2. So just a little bit steeper than my 1. So I said all my -1s. Let's do all my zeros. 0, 0. I'm just going to get a -1. Oh, 0. Sorry, I was being silly. 0, 1. I get a 0 again. We're going to see that anything that has a 0 on my output is going to be a 0. Sorry, this should have been a 2. Okay, I'm going to do my last chunk over here because I'm running out of space. I encourage you guys to try this last row of 1 on your own. Yeah. So we just drew a slope field. Okay, we're going to go ahead and do B on the next video. So go ahead and switch to the next video. I don't want us to cut these off. The videos can only be 15 minutes long, so find the next video.